A car accelerates uniformly from 18 km per hour, so which is u, to 36 km per hour, that is v, in 5 minutes, which is time. So you have u 18 km per hour, your v is 36 km per hour, and the time is 5 minutes. We're going to work this sum in kilometer per hour, so the minutes has to be changed into hours. So 5 by 60 will be changing the 5 minutes into hours. So we have A equal to V minus U over T. The V is 36, the U is 18, and the time is 5 by 60. The minutes we have changed into hours. So this is 18. We can cancel this off here, and this becomes now 12. So this will be 18 over 1 by 12, which is equal to 18 divided by 1 by 12, which is equal to 18 into 12, and equal to 216 km per hour square. So here is the right option. What does the area of the velocity time graph give us? Here we have, this is velocity and time, and this is the graph. The velocity increases, remains constant, and then it decreases. Now this area within the velocity time graph and the axis, and the time axis, this is the velocity time graph, and here is the time axis. The area between that always will give you displacement or the distance. Now in this the next graph, if you want to find the distance covered from between 1 second and 2 seconds, what you do is, this is your velocity time graph, and here is your axis. This area between the velocity time graph and the time axis, we call this area, say, S1, will give you distance between, this is S1, between 0 to 2 seconds. Now if you want to find the distance between 2 and 4 seconds, then the area there will be, this is your velocity time graph, and here is your time. This area, this entire rectangle that you can see here in the yellow, we'll call this as S2, and S2 will be the distance covered between 2 and 4 seconds. And if you want to find the distance between 4 and 6 seconds, here is your velocity time graph, and this is your time axis. This area in between, we'll call this area S3, will give us distance covered between 4 to 6 seconds. So this area of the velocity time graph and the time axis always gives us the displacement. Here we have the velocity, the slope of xt graph. Now this is distance versus time. Now distance versus time graph, the slope of this will always give us velocity. So to find velocity, we must first know the displacement. From the graph we find the displacement, and we find the time for which the displacement has taken place. So here at this point the distance here is 0, say d1 is 0, and then at this point here the distance 2 is 6 meters. So the displacement of the body will be 6 minus 0, that is 6 meter. Now this has happened in a time of 3 seconds. So time equal to 3 seconds. So the velocity will be displacement over time. Displacement 6 times 3, which is 2 meter per second. So this is your right option, 2 meter per second. A particle accelerates from rest. So the body is first at rest, and then it attains a constant velocity of 8 meters per second. Afterwards, it deaccelerates at a constant rate and comes to rest, and the total time is 4 seconds. Find the distance traveled. So if I were to draw this graph, I would say it moves up here, it accelerates, and then it slowly comes to rest. So this is the graph. Now to find the area, it would be, this area would give me the distance, and that area would be half base into height, because it is a triangle. And if you notice here, the base is 4, here is the base, and this is the height of the triangle. So base is 4 and the height is 8, so it would be 16 meter. Half base into height. It accelerates here and then it retards here, slows down. A car travels 100 kilometers east and then 100 kilometers south. Finally, it comes back to the starting point by the southeast route. Throughout the journey, the speed is 60 kilometers per hour. So find the average velocity. Now average velocity equal to displacement over time. Now this object comes back to its original starting point. So which means displacement is 0. And we don't even want to know the time. It's not important, because for sure the velocity will be 0 meter per second. Or here actually everything is in kilometer per hour, so it's not right when I say meter per second. It would be kilometer per hour. A ball is thrown up with a velocity of 20 meters per second. What is the time of flight neglecting air resistance? So here is the earth, and from here the ball is thrown upwards. So with an initial velocity of 20 meters per second. So right in the beginning, its velocity will be 20 meters per second. It is thrown out with 20 meters per second. The speed will slowly decrease, and after some time it will become 0 meter per second at the end of the journey. And once it becomes 0 meter per second, it sort of stops, and then it starts returning back. Now let t be the time taken for it to go up. So when it's thrown up, we know it is thrown 20 meters per second. It finally stops. Every stone that is thrown up, you see it finally stops and then comes back. So the final velocity 0 meter per second. The time is, we don't know. And here the acceleration is that of the gravity, which is given as 10 meter per second square. And I'm putting negative. Now why am I putting negative? Because this object is retarding. The velocity keeps on decreasing slowly. So when an object is thrown upwards, it is retarding. So the g has to be taken as negative. So we do v equal to u plus at. The final velocity is 0 because as you throw the object up, it slowly decreases and stops. The u was 20. The a we know was minus 10. You know why minus have we taken? Because it's retarding, and time we don't know. So 0 equal to 20 minus 10t minus 20 equal to minus 10t, and you get your t as 2. Now to go up it takes 2 seconds, and to come down it will also take 2 seconds. So the total time of the journey will be 2 plus 2, and that is 4 seconds. So your correct answer is 4 seconds. Not 2 seconds. 2 seconds is one way. It goes up and comes back. So 2 plus 2, 4. The velocity of a body is reducing. It is said to have both negative acceleration and a retardation. What is retardation? Negative acceleration. When the velocity of an object keeps on decreasing, it is said to be retardation or negative acceleration. Like from 30 meter per second, the object stops, comes to rest, means 0 meter per second. Or say from 100 meter per second, it would become say 20 meter per second. Here when you calculate your acceleration, it will come negative. A signal from a spaceship reaches the ground in 5 minutes. So time is 5 minutes. So I just write it out here. We cannot work in minutes. We are going to work in seconds. So we put 5 into 60. So this would be 300 seconds. What was the distance of the spaceship from the ground if the speed of light was 3 into 10 raised to the power of 8 meter per second? So this is speed. So I'll write speed. As we sometimes take a distance, here it is speed. 3 into 10 raised to the power of 8. Now if you remember the formula, distance equal to speed into time. We can use this formula when there is no acceleration. If there is acceleration, we got to use your equations of motion, which is that v equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as when there is acceleration. If there is no acceleration, we do distance equal to speed into time. So the distance we need to find, the speed is 3 into 10 raised to the power of 8 and time is 300. And when you work this out, you get 9 into 10 raised to the power of 10 meter. So I think this is the answer here. 9 into 10 raised to the power of 10 meter. The VT graph, from the VT graph, it can be inferred that the object is, now here it is not an object at rest, it has a velocity. The velocity is constant. Here for this, velocity is constant because it is a straight line. If you say body at rest, wrong. This is wrong. So it is constant velocity. Constant velocity means it is moving with uniform speed, and this is called uniform motion. So the right option for this is uniform motion. In uniform motion. So it could be moving with uniform motion also, but definitely it could be the 3 or 4. A body moves on 3/4 of a circle of radius r. Find its distance and displacement. So if the object were to start here, say at this point A, it is going 3/4. 3/4 means it is moving right round here till here. This is 3/4. So this would be your point B. So definitely you know your distance. This is the actual path covered by the object. It is 3/4 of the circumference. So 3/4 of 2 pi r. And when you cancel this, you will get here 1s are, 2s are. So this would be 3 pi r by 2, and this you're calculating is your distance. Now if you want to calculate your displacement, you have to know which is your initial position was A, your final position was B, and this is your displacement. AB is your displacement. How do we go about calculating AB? So we'll join it to the center. This is our center here. You see O. This is radius and this is radius. So in triangle AOB, I use Pythagoras theorem. So OA square plus OB square equal to AB square, which means R square plus R square equal to AB square. 2R square equal to AB square. AB is under root of 2R square. R into under root 2 equal to AB, and this is our displacement. So the right option is 4. The slope of velocity time graph. Velocity time graph will give us acceleration. Now who will give us speed? The slope of distance time graph. Who gives us displacement? Displacement will be given by, no, displacement and distance we cannot get it. We need to straight away plot for distance and displacement. But speed is given by distance time graph. However, velocity time graph, like we said just now, will give us acceleration. Distance time graph gives us speed, and displacement time graph will give us velocity. The equations of motions are applicable only to uniform acceleration, where the acceleration remains constant, uniform acceleration. The given image of distance time graph represents, now this is distance time graph, and here it is a constant. So distance is constant, which means the body is not moving at all. So the body stops moving. If it was same one, if it was velocity time graph and that was a straight line, now this is not a body at rest. This is body with constant velocity. Constant velocity means velocity remains same, so it is uniform motion. And if you say acceleration is equal to 0, because the velocity is constant and does not change. The image shows a graph of distance traveled against time. The graph is meant for, have you seen, this is non-linear, non-uniform motion or non-uniform speed. It will be this, the speed will keep changing. If the body moves through C and B and reaches A, so let's take that up. So the body starts at this point O and it goes straight down B, C and reaches A. So here it has moved, if you see, 60 kilometers. When it goes up like this, it has moved 60 kilometers. It is covered OA. And then it comes back, reaches C through B. So it comes back here till C. Now how much would that be? 1, 2, 3, 4, 5, 6, 7. And that would be, is returning back would be 7 into 5, 35 kilometer. And that would be now AC. So the total distance it has moved would be 95 kilometer. However, if they asked you the displacement, then it would have been initial position, final position. This would be a displacement, the red line. So it's 1, 2, 3, 4, 5. So the displacement would be 5 into 5, and that is 25 kilometer. A car travels 10 meters in 5 seconds, 20 meters in the next 10 seconds, and 30 meters in the last 10 seconds. Find its average speed. To find the average speed, we have to know total time over total distance. So in the first part, the distance you see is 10 meters and the time is 5 seconds. Then in the second part, you can see the distance traveled is 20 meters and the time is 10 seconds. And in the last part, the third, distance is 30 meters and time is 10 seconds. So if you want total distance, will be 10 in the first, 10 plus 20 plus 30, and this will be 60 meters. And if you want to find total time, will be 5 plus 10 plus 10, 5 plus 10 plus 10, which is 25 seconds. Now to find average speed, it should be total distance over total time. Total distance 60, total time 25. You then you reduce it by 5, so you have 12 by 5. So 12 by 5 meter per second. For an uniformly accelerated body, the average velocity is given as initial velocity plus final velocity over 2. But if the body is not uniformly accelerated, they do not mention it's uniformly accelerated, then the velocity or the average velocity is given as displacement over time. So now it depends which formula to use. If it is uniformly accelerated, the average velocity is u plus v over 2. But if they just give you velocity, they're talking about displacement, then it is displacement over time.